Okay, so in this one, the denominator is actually not factorable. Okay, so, and we have a trinomial. So I'm going to try the other, really only other approach, which we saw in trig substitution a lot, is to complete the square. So x squared plus 4x, to complete the square I need a 4. Okay, if I subtract the 4 from there, I get a 9. Okay, so 0 to 1 x, then we get an x plus 2 squared plus 9. Okay, so this is not factorable still. What we have here is something that looks like a trig substitution, right? So it looks like maybe we can replace x plus 2 with, for example, a tangent theta. But we're going to have a problem because it's not x but x plus 2. The other thing that actually I didn't mention up here, if you go back all the way back to substitution method, you might have guessed that because the degree at the bottom is 2 and the degree at the top is 1, we should try substitution. So let me actually make that substitution here. Let's just try it, see what happens. Let u equal to x squared plus 4x plus 13. Then you get du is equal to 2x plus 4, 2x plus 4 dx. So let me actually divide both sides by 2. Half du, you get x plus 2 dx. Okay, so I don't have an x, right? I have a I need an x plus 2, but I don't have an x plus 2. I only have an x, right? Okay, so let me introduce. Okay, let me introduce an x there, a plus 2 there, like that. Okay, so don't worry about this. We still need this, but this is actually what I should have done first. Okay, so this is very nice right now because I can use this substitution to solve, to find the antiderivative of that. Okay, so then because I added a 2, I gotta subtract a 2 as well, right? Okay, so by substitution, this can be replaced with a half of du over u. Okay, that's good. So this here, let me replace it back with this completely the square form. So you have an x plus 2 squared plus 9. Okay. Now in this form, you can actually use either trig substitution or modify it so that because you recognize this is a modified version of arctangent. Okay. Okay, so I'm going to choose to do it by the trig substitution. So let x plus 2 equal to x plus 2 equal to 3, because of this 9 at the back, 3 tangent of theta. So then you get dx is equal to 3 secant squared theta d theta. Okay. So this first part is just going to be half of ln of absolute value of x squared plus, right, u, which is x squared plus 4x plus 13, minus 2. Dx can be replaced with that. So 3 secant squared theta d theta. And x plus 2 will be replaced with 3 tangent theta squared. So we're going to get a 9 tangent squared theta plus 9 here. Okay. All right, so let me continue here. All right, so you can divide the top and bottom by 3 and factor out that 3 to get negative 2 over 3. You have a secant squared theta d theta. At the bottom we have a tangent squared theta plus 1. Okay, that's exactly secant squared theta. Gone. Okay. (4x plus 13). So this is going to be theta plus constant, where theta from here, so tangent of theta is equal to x plus 2 over 3. So theta must be arctan of x plus 2 over 3. Okay, that's exactly what we need. On arctan x plus 2 over 3. So last step, we actually have to plug in 1 and 0 in there. So let's plug in 1, and you get half of ln of 1 plus 4 plus, right, 13. So that's 18, right? 18 minus 2 over 3 ln of, sorry, arctan of. So if you plug in 1 in there, you actually get arctan of 1, which is pi over 4. Okay, minus half, let's plug in 0, and we get ln of 13. Okay, minus 2 over 3, if you plug in 0 in there, you get just arctan of 2 over 3. Okay, so this, I don't think it really, maybe you can combine these two lns with a factor of half. You get ln of then 18 minus ln of 13, that's 18 divided by 13. Okay, and we have a minus reduced, so you get pi over 6 and a plus 2 over 3 arctan 2 over 3. So that's all you can do. If you want a different form of this answer, you got to punch it in the calculator and get the decimal value.